In this video, I'm going to show you how you can build the server side of your applications using the excellent open source tool Postgraphile. So what's Postgraphile and why would you want to use it? Well, Postgraphile is an open source project for creating high-performance GraphQL servers that primarily use Postgres databases, and the reason you might be interested in using Postgraphile is because with it, you can build the server side of your applications in a fraction of the amount of time it would take to build a server using most modern programming languages and frameworks. So developing with Postgraphile is fast. You can get your server built really quickly, but you might be wondering, what is it about Postgraphile that speeds up the development process? To answer this question, let me explain how Postgraphile works in the simplest case. Basically, to use Postgraphile, all you need to do is create a well-structured database and point Postgraphile to the database, and then Postgraphile will inspect the database schema and automatically create a GraphQL server that your application can perform queries against. So basically what I'm saying is, with Postgraphile, you might be able to create a server without writing any server-side code, which obviously can save you a ton of time. Now you'll definitely need to write some SQL to create tables, views, and maybe some SQL functions, and a few other database-related things, but these are the kind of things you're already doing in a conventional server project. But with Postgraphile, after you've written the SQL needed to create a well-structured database, there's a very good chance your server is done and ready to be used with your application. Alright, so how exactly do you use Postgraphile? Well, that's what we're going to cover in this video. Now, there's a couple of soft prerequisites for getting the most out of this video. You should be somewhat familiar with both SQL and GraphQL. Now, I'm not saying you need to be an expert in both of these to watch this video, but it might be a bit challenging to follow along if you're a complete newbie with these technologies. Okay, are you ready? Let's get started. I'm going to show you how to use Postgraphile by building an actual Postgraphile server for a web application that we'll look at right now. So what's the web app we'll be building? Well, it's essentially a flashcard app that you could use to help learn new things, but it's more than just a flashcard app because we're going to implement it to use spaced repetition. So what's spaced repetition? Well, hold that thought for now. I'll explain in just a moment here. But first, let's take a look at some drawings of the web app that we're building the server for. Let's start by looking at the cards page you see here. This page lists all the flashcards for the signed-in user. From this page, you can edit an existing card, archive a card, delete a card, and create a new flashcard. If you click on the Add Card button, you'll be taken to this page where you can enter a question and the corresponding answer. Now, once you've created a few flashcards, the home page will show you how many cards need to be reviewed, and clicking the Begin Review button will take you to the review page where you're prompted with a flashcard question like you see here. Okay, as a user, when you see the question, you'll attempt to answer the question in your mind, then you'll click the Show Answer button to see if you remembered correctly. Now, when you view the answer, you'll also see these 4 buttons, which allows you to score or grade how well you remembered the answer. So for example, if you remembered it perfectly without thinking about it, you'd click Easy. And on the other end of the spectrum, if you couldn't remember the answer at all, you'd click Again. You're probably wondering, what happens when you click these buttons? Well, to answer this question, I need to circle back to the concept of spaced repetition. So what is spaced repetition? Well, first of all, let's briefly talk about the human brain. Our brains can hold a ton of information. In fact, it's estimated that our brains can store somewhere between 2 and 3 petabytes of data. That's enough storage for about 200 to 300 years of recorded video. So our brains can store a lot of information, but unfortunately our brains don't work like we might want them to. I mean, if our brains have so much capacity, why are we always forgetting things like where I put my car keys or where I left my iPhone? Well, there's a lot of reasons why you forget things, but I'll give you one big reason. It's pretty healthy to forget some things. For example, imagine what your life would be like if you remembered all the bad things that happened to you since you were born. Yeah, I don't know about you, but I'm totally okay forgetting the bad stuff. Okay, so how does your brain decide if it should hold on to a memory or let it go? Well, this is where the concept of spaced repetition comes in. Our brains have what's called a curve of forgetting, which is essentially a plot of memory retention over time. Well, let me give you an example of how this curve of forgetting works. Imagine I've got a rope, and I show you how to tie a special knot, then I hand you the rope and I ask you to tie the same knot. You might be able to tie the knot on your first try, or you might have to watch me do it one more time, but pretty quickly you'll be able to tie the knot. Now the question is, how long will you remember how to tie that knot that you just learned? Well, typically, most people will remember how to tie the knot for around 24 hours, but soon thereafter, the memory will fade and you'll forget. Now, an interesting thing happens if you practice the knot just before it falls out of memory, right around the 24-hour point. Basically, by practicing the knot again, your mind says to itself, hey, I'm using this memory again, so it must be kind of important. So the memory is strengthened, and you've got a new curve of forgetting, which is around 3 days. Now, if you practice that knot again 3 days later, your memory is strengthened even more, and now you'll hold on to this memory for about a week, and every subsequent time you review that memory, just before you'd normally forget it, you're strengthening that memory, and the curve of forgetting grows and grows and grows. So the idea of spaced repetition is that you can sort of hack your brain into remembering things by recalling a memory just before you'd typically forget it. And the nice thing about spaced repetition is that you can memorize things with the least amount of effort possible. Okay, so now that you've got a sense of what spaced repetition is, do you have any ideas on what these buttons are for? Well, basically, clicking these buttons will set the spacing interval on when to review this card next. So if you click the Again button, it means you totally forgot the answer, and you need to reset the spacing interval to 0. In other words, you need to practice this one again right now. And as you can imagine, clicking the other 3 buttons will set the spacing interval to different points in the future. Okay, so there's 2 takeaways from this little discussion on spaced repetition. First of all, you should use spaced repetition when you learn new things because it's one of the most efficient ways to do so. Secondly, the server we need to build isn't just a dumb CRUD interface. There's a bit of logic to it that we'll need to implement, but how do you implement server-side logic if all you're doing is creating a database? Well, stay with me and you'll see. Alright, there's 2 other pages I want to look at real quick. A page for creating an account and a page for signing in. So basically, we'll need to somehow implement user registration and authentication. Okay, let's start coding. I've got my editor open, and you'll notice that this project is mostly empty, except I initialized it with git and npm, and I've got an RC file that specifies what version of Node.js to use, but for all intents and purposes, we're starting with an empty project. Now keep in mind, the vast majority of what we'll be doing going forward in this video is creating a well-structured Postgres database that can be used by our flashcard application. So how are we going to create the Postgres database? We'll be using a database migration tool named dbmigrate, which exists in npm, the Node package manager, so I'll go ahead and install it right now. Of course, you don't have to use dbmigrate. You can use whatever database migration tools that you prefer. Next, I'll install the dbmigrate PG library, which includes the appropriate drivers so dbmigrate can talk to the Postgres database. Okay, I've already got Postgres installed on my Mac via the excellent Postgres app. If you're following along on your own, you'll need to make sure a fairly recent version of Postgres is installed on your computer. I'm using Postgres version 10 for this video. Next, I'll create the database we'll be using by keying create_db, and I'll name the database learn_dev. Now I'll use Atom, my editor, to create a new config file for dbmigrate named database.json. Next, I'll create a dev key, which has an object literal with the configuration information. The driver will be PG, the Postgres driver. The host is localhost, and the database will be the one we just created, learn_dev. Now keep in mind, depending on how you set up Postgres on your computer, you may need to pass additional configuration options, such as a username and password, but in my case, where I'm using the Postgres app, I don't need to pass any credentials along. Okay, our initial setup and config is done, and now we can begin the process of structuring our database for our flashcard app. So to create a migration file, I'll pull up the terminal, and I'll key npx, the command line tool that comes with npm, then I'll key dbmigrate, create, then I'll provide a file name of my choosing, which I'll call create schema, and lastly, I'll add the option SQL file. This SQL file option will basically create 2 plain old SQL files that we'll use to specify how we'd like the up and down migrations to work. You'll see what I mean by this in just a moment. Okay, so this command completed successfully, and you can see that it created 3 files in a new migrations folder. These 2 files here and here are the files we'll be modifying to construct our database. Notice that the name of the file is essentially a combination of a timestamp, the name we specified here, and either up or down. The up file will include the new things we want to add to the database, and the down file will define how to remove the things we add in the up file, essentially allowing us to revert the changes made in the up file. Okay, let's open up the new migration files that are located under the migrations folder and then within the sequels folder. The first thing we'll be adding to our database is a new schema named learn. I'll do this by keying create schema learn. Now, there's a good chance many of you have worked with databases for many years, but never did anything with schemas like this. And you're probably wondering, what exactly is a schema in Postgres and why am I creating it? You can think of a schema as just a namespace for now, and the namespace is kind of like a folder that we'll be putting stuff in, such as the tables we'll be creating in just a moment here. Now, as many of you know, you don't need to create a custom schema when you're using Postgres. You could just use the default public schema, and if you're using the public schema, you probably don't even really think about it. So why are we adding a custom schema? Well, I'm not going to tell you why just yet. We need to cover a few more things still, but I'll give you a hint. The reason we're creating a custom schema has to do with security, or more specifically, it has to do with what information is made available by the Postgraphile server, but more to come on schemas in a bit. Next, I'll open up the corresponding down file, and I'll say drop schema learn. This command essentially removes the schema that gets created in the up file. Okay, now let's apply our migration in the terminal by keying npx dbmigrate up, which will run any commands in the up file. Alright, we see the SQL command that was run here, and there were no error messages, so all is well, it worked. Now, if we wanted to revert the migration we just ran, we'd simply run npx dbmigrate, and any guesses what comes next? Yep, down. And as you can see, this SQL command was executed, and our database no longer has the learn schema. Of course, we do want the learn schema in our database, so I'll go ahead and run the migration again. You know how I added this SQL file option right here? I don't want to have to add this option every time I create a new migration, but I do want all of our migrations to be plain old SQL files instead of JavaScript files, which is the default. dbmigrate allows you to specify default options by creating an RC file, or run command file, which I'll do right now in the Atom editor. The name of the file will be .dbmigrate.rc. The RC file contains JSON, and I'll specify that SQL file option should be true. Okay, I'll close all the files that are open in my editor, then in the terminal, I'll create a new set of migration files, and I'll name it create table person, but this time I don't need to add the SQL file option. Alright, we see the new migration files here, which I'll open up in my editor. In this migration, I'm going to create our first table called the person table, and I'll do this by keying create table, and then I'll enter our custom schema name, learn.the table name, which is person. Then I'll add an opening and closing parentheses. Next, I'll add the columns I'd like this table to have, starting with an ID column of type serial, which is the primary key. Then I'll add a first name column of type text, and I'll say it can't contain null values. Similarly, I'll add a last name column, and lastly, I'll add a created at column, timestamp with the time zone, and I'll set its default value to be the current time or the time now. Now I'll define how our down migration should work by saying drop table learn.person. Okay, let's create our new person table by running our migration, and it was successful. Alright, now that we've got a table in our database, we can start using Postgraphile. So I'll go ahead and install Postgraphile by keying npm install Postgraphile. Okay, so the next question you probably have is, how do you actually start or run Postgraphile? Well, there's a couple of ways. You can run it like a Node.js middleware with many of the popular Node.js servers like Express.js or Koa. The other option for running Postgraphile is to simply run the Postgraphile command that was just installed with the Postgraphile library. In this video, we'll just run the Postgraphile command, which we could do right here in the terminal, but we'll be specifying quite a few different options to the Postgraphile command. So to make things easier on ourselves, I'm going to create a shell script named server.sh, and I'll make it executable. Next, I'll open up our new script file in Atom. So to start Postgraphile, I'll key npx postgraphile, then I'll extend the command onto the next line, and I'll add the database connection string it should use by keying the -c option, followed by a valid Postgres connection string. In my case, the connection string will be pretty minimal. I'll key Postgres, ://, and often you'll provide some credentials to use next, right here. However, in my case, I don't need to provide credentials, at least for now, so I'll add another slash, and I'll specify the database name, learn_dev. Then I'll continue the command on the next line, where I'll add the schema option, and I'll tell Postgraphile to use the custom learn schema. So do you remember a few moments ago when I posed the question, why are we creating a custom schema? I bet seeing this option right here is starting to answer that question in your mind. Basically, we're telling Postgraphile to only expose things it finds in the learn schema. So for example, if we wanted to create some tables in some other schema, Postgraphile won't expose those tables. The reasoning behind why we're using schemas will become even more clear a bit later when we set up user registration and authentication, so hang with me for now. Okay, let's start up our Postgraphile server by keying ./server.sh, and as you can see from the response, it looks like it worked. I'm going to click on this link right here, which will open up the GraphQL tool, which we'll be using extensively through the remainder of this video. Okay, so what is this graphical tool, and how do we use it? Well, this is where we'll be writing and trying out our GraphQL queries. Now, if you're not super familiar with GraphQL queries, you can think of them sort of like SQL queries. Well, not exactly, but it's a reasonable analogy to start with. Basically, we can write GraphQL queries to fetch data from things like tables, and we can write queries, or what's called mutations, to add new rows to tables, or to do updates and deletes, plus a bunch of other operations, many of which we'll cover later in this video. Let me give you an example of a query to fetch data from our new person table. So to do this, I'll enter the keyword query followed by an operation name for this query, which I'll call people query. Then I'll add a set of curly braces, and I'll start keying the letter A, and we see that Graphical gives us some options for auto-completing what I started typing. This first option, all people, looks pretty relevant for the person table, so I'll finish adding the field name, then I'll add another set of curly braces, and I'll add the keyword nodes, followed by a set of curly braces. And now I'll press the hotkey Control Space, and we see a few fields listed, the last 4 of which match the column names in our person table. I'll start by selecting the ID field, then I'll select the first name field and the last name field. Okay, this is a valid GraphQL query that is essentially saying, fetch me all the people, but only return each person's ID, first name, and last name. I'll go ahead and run this query by clicking the Run button here, and we see the results of this query over here. Basically, we get an empty array as the response, which makes sense because we haven't actually added any people to the person table. Let's do this. I'm going to pull up a SQL tool I use named Postgraphile, and I'm going to run the following SQL command. Insert into learn person, then I'll specify the first and last name columns, and I'll say the values to insert are a few first and last name combinations. Now I'll run this command, which inserted 3 new rows, and we'll pull up Graphical again. And I'll run this query again, and this time we see the 3 rows I just inserted. Cool. Okay, I didn't need to insert these new person records with SQL like I just did. We can also insert records into a table using GraphQL. I'll get rid of this query, then I'll create what's called a mutation, and I'll name this mutation create person, and I'll add a set of curly braces. Next I'll type the letter C, and notice what shows up in the autocomplete here. It's a GraphQL field name, create person, which does exactly what you'd expect. It allows you to create a new person. Now the next question you probably have is, how do you pass along the first and last name of the person to create? Well, you do this by passing in some parameters to this create person field. So to do this, I'll add a set of parentheses, and then we automatically see an autocomplete suggestion that includes this input identifier. I'll go ahead and use the input parameter, followed by a colon and a set of curly braces, and then I'll enter person, followed by a colon and a set of curly braces, and then we see the input fields for the person table. Next, I'll add the first name of Joe and the last name of Smith, and I won't worry about the ID and the created at columns, as these are auto-populated. Okay, if you notice the red squiggly lines here under create person, it's an indication that our mutation isn't valid. We need to specify what information should be returned after creating a new person. So I'll add a set of curly braces, then I'll key in the person field, indicating I want the newly created person to be returned, and I'll say return the ID, first name, and last name. Now I'll run this mutation, and we know it worked because there were no errors, and we see the newly inserted person right here. Cool. We can also do updates in GraphQL. Let me show you an example. Let's say we'd like to change this name from Joe to Joey. So to update the name, I'll create a new mutation named update person, then I'll use the field that Postgraphile offers us named update person by ID, and I'll specify the input should include the ID of the record to update, 4, and I'll add the person patch parameter, where I'll say to update the first name to Joey, then I'll return the updated person's ID, first name, and last name. Now I'll run the update person query, and as you can see over here, it worked. We can also perform deletes with GraphQL, which I'll demonstrate right now. I'll create a new mutation which references the delete person by ID field, and its input includes the ID to delete, and then I'll specify what data to return, which in this case is the deleted person's ID and first name. Now I'll run the delete person mutation, and it worked. Okay, so hopefully this gives you a general sense of what Postgraphile gives you, but we've barely scratched the surface, so hang with me, as there's a lot more to see. Now, by default, Postgraphile uses some rather long names for the GraphQL fields. For example, a few moments ago we ran this query, and the field name we used was all people. I kind of wish it just said people here. Well, this simpler naming convention can be achieved by using a custom Postgraphile plugin. Let me show you how this works. First, I'll kill the server by pressing Ctrl+C. Next, I'll install the Postgraphile plugin I'm referring to by keying npm install at postgraphile-contrib/pg simplify inflector. Now we've got to tell Postgraphile to use this plugin. To do this, I'll pull up our server shell script, and I'll continue the command on the next line, adding the option append plugins and providing the plugin's module name. Alright, I'll restart the server, then I'll head back to GraphQL, then I'll click the history button and click people query. So this is the query we ran to fetch all the people, but notice what happens when I run this query again. We get an error that says it can't find the field all people. Well, that makes sense because the plugin we just installed should now make the field name people, not all people. I'll go ahead and get rid of the query, and I'll press Control Space, which gives us a list of all the fields we can query against. Why do you think we still see all people listed? Well, the reason is because we haven't refreshed the browser since restarting the server, so the GraphQL metadata stored in the browser is out of date. This is easy to fix by just refreshing the page. And now when I press Control Space, we see the field name we expect, which is people. So I'll go ahead and choose the field people, and I'll create a query similar to what we ran earlier, and when I run this query, we get the result we're expecting. Okay, so here's the takeaways I want you to remember about what we just did when we added the plugin. Postgraphile offers a bunch of functionality which covers the vast majority of use cases you'll ever need to handle, but if you happen to run into a scenario that Postgraphile doesn't handle, you might be able to extend Postgraphile with a community plugin, or you can write a plugin yourself, but honestly, you probably won't run into any showstoppers that requires you to write a plugin. I want to enable a couple of additional features to Postgraphile that will add some interesting features to GraphQL. To enable these features, I'll add the Enhance Graphical option and the Allow Explain option. Next, I'll kill the server and restart it. Now I'll pull up the browser and refresh the page, and as you can see, this page looks a bit different now. In particular, these two buttons are new. The Explorer allows you to see all the fields and parameters that are available to you and lets you create queries and mutations by simply selecting what you want. For example, when I click the Created At checkbox, you'll notice the field gets added to the query over here. The Explain button shows the results of using Postgres' explain keyword on a query. Basically, it can help you determine how efficient the underlying SQL query is, and if the query is inefficient, you can address the issue with indexes or other fixes. Below the Explain section is the SQL used to fetch this data up here. Okay, I bet I know what many of you are thinking as you're looking at this SQL. You're probably thinking, that doesn't look like any SQL I've ever seen. Yeah, I get it. It's not what you're probably used to seeing, so what's going on here? Well, keep in mind, these SQL queries are generated dynamically based on the GraphQL query, and some optimizations are happening to minimize the number of queries that get sent to the database. In fact, for every GraphQL query tree, like this, GraphQL generates just one database query, and it avoids the n+1 problem. So the SQL might look a bit crazy at first glance, but it's quite efficient. I also want to point out the documentation in GraphQL, which you can open by clicking right here. Basically, the docs provide a description of the entire GraphQL schema. In other words, it shows all the possible queries, mutations, fields, parameters, data types, and so on. So for example, I could search for person, and I'll see all sorts of fields and types associated with our person table. If I click on this person type, we see the table columns listed here. However, notice that there is no description for the person, and there is no description for each of these fields. If we'd like to improve the documentation that we see here, we can do this by simply adding some comments to our database. Let me show you how this works. I'm going to go ahead and kill the server, then I'll create a new migration. Now I'll open up our new migration file, and I'll add some comments to the database. First, I'll add the comment to the table LearnPerson, which is a user of the flashcard app. Next, I'll add some comments for each of the columns in the table. And actually, I'm not going to bother to create a down migration script for these comments, since it's not necessary. Now I'll run our migration and start up the server. Next, I'll pull up the browser and refresh the page. Then I'll open up the docs and search for the person type. And check this out. The comments we added here are now displayed here. Nice. Okay, it's getting kind of annoying to have to kill and restart the server every time I make a change in the database, but this can be avoided if we enable another feature when we start the Postgraphile server. So to do this, I'll extend the command to the next line, and I'll add the watch option. Now, anytime we apply a migration, Postgraphile server will notice the changes and automatically update the server, and it'll automatically push the metadata changes to GraphQL in real time. Alright, I'll kill the server and restart it with the new watch option, and I'll open up another terminal session where we can work with the migrations. It's time to add another table, the card table, so I'll create a new migration, and I'll open the new up and down files. First, I'll create a table in the learn schema named card. Then I'll add the ID field, then a question field of type text, an answer field, and a review after timestamp field. Next, I'll add a spacing field of type integer, and I'll add a check, which basically enforces that the spacing field must be greater than or equal to 0. Now, if we were building a traditional server, using whatever your favorite language is, you'd typically need to validate values sent from users in your server code. But in the case of Postgraphile, we're not writing typical server-side code, so we need to lean more on the features in Postgres to validate and check values. So in this case, we're having Postgres validate the spacing column value right here. Next, I'll add an ease factor, which is a numeric type, and we're having Postgres verify or check that its value is greater than or equal to 1.3. Next, I'll add a sequence column. Okay, you're probably wondering what these 4 columns are for. Well, they're going to be used to determine when a flashcard should be reviewed next. Essentially, these 4 fields will be used by a simple spacing algorithm we'll implement in a bit here. And an important thing to know about these 4 fields is that they should never be manipulated by users. They should be set exclusively by our spacing algorithm. So somehow we need to control access to these columns, but I don't want to deal with this just yet. We'll come back to this in a moment here. Next, I'll add an archived column, followed by a person ID column of type integer, which references the person table's ID column. This person ID column will hold the unique ID of the person who created and owns each flashcard. Lastly, I'll add a created@at column. Next, I'll add in a few indexes for this table, an index for the review after column, the archived column, and the foreign key person ID. Now I'll add some comments on the table and each column in the table. In the down migration, I'll simply drop the table. Next, I'll go ahead and apply this migration. Okay, we don't need to restart the server since we've added the watch option, and we don't need to refresh the browser either, so I'll just add a mutation to create a new card, and I'll run the mutation, and it worked. We added this flashcard data. Cool. Now, there's a problem with this mutation. Do you see what the problem is? Well, remember how I said these 4 fields shouldn't be manipulated by users? Well, I just manipulated the spacing value. I set it to 100, which will break our app. But there's another, similar but more subtle problem, which is the fact that I'm specifying the ID of the person right here, but should we really trust the user to pass their ID in this query? If the user was devious, they might just send a query like this with some other user's ID, effectively corrupting the other user's set of flashcards. Really, this person ID should be set by the server based on the logged in user, right? Okay, so how can we fix these issues? Well, in part, we can address them with something called smart tags. Let me show you how this works. First, I'm going to roll back the last migration for the card table. Next, I'll rearrange the comments a bit. And then I'm going to modify the comment for the review after column, adding a special comment called a smart tag that is @omit, the ability to create and update values in this column. Then I'll separate the smart tag from the comment with a new line. Now we'll do a similar thing for the other column comments. Okay, so what does this do for us? Well, it'll prevent these fields from being updated by users via our Postgraphile server. Let me show you. First, I'll reapply our migration. Then I'll pull up the browser and check this out right here. GraphQL is complaining about us trying to add values to the person ID and spacing columns because it's not allowed to anymore. Nice. So can we still view the spacing field in the person ID field? Let's create a query in C. So I'll add a card query that includes the spacing and person ID, and as you can see in GraphQL, it isn't complaining about them. So yep, we can query these fields. Now we still need to figure out a way to set the values in these fields, but we'll get to that in just a bit here. There's another field available to us in the card query that I want to draw your attention to. I'll go ahead and enter the letter P and take a look at the fields that show up in the autocomplete list. Check out this first one right here, person. So what's going on with this field? I mean, we don't have a person column in the card table, so what is this? Well, since we added a proper foreign key to our card table, Postgraphile automatically added the person field, which allows us to easily query information about the owner of this card. So for example, if I wanted to include information about the owner of the card, I'll just add the person field, then I'll add a subselection of the fields I want to include from the person table. I'll add the person ID, first name, and last name. Now when I run this query, we don't get any results because I just dropped the card table and recreated it, but for the moment, I'll do the following. I'll insert a row into the card table using this SQL statement, then I'll run the query again, and as you can see, we were able to query our new card and the person who owns the card. Cool. Now it's worth noting that the smart tags are easily bypassed with this SQL expression, but we'll address these types of security concerns more in a bit here. The next thing I want to do is add a new table, so I'll create a new migration to create a response table. This response table is essentially a log of the response the user provides when reviewing a flashcard. So I'll add in the appropriate columns for the response table, then I'll add some indexes as appropriate, and I'll add some comments. Now I don't want users to be able to create, update, and delete rows in this table, well at least not directly. So to prevent Postgraphile from performing creates, updates, and deletes, I'll add a smart tag on the table comment to omit create, update, and delete operations. Now I'll apply our migration. Okay, to reinforce what we just accomplished with smart tags in the response table, I'll start a query, and if I start to type response, we see some response fields available to use, confirming that we can read from the response table, which is what we want. But look what happens when I start to create a mutation. When we look at the available mutation fields, we don't see any fields to create, update, or delete responses, which is what you'd expect with these table-level smart tags. Oh, one more thing. We need to drop the response table in the down migration file. Okay, the next thing we'll add is a couple of Postgres functions to handle the process of scoring how well you remembered the answer and setting the appropriate spacing. In other words, setting the next time the card should be reviewed. So I'll create a new migration. Then I'll open up the new migration files. I'm going to write this function offline, then I'll briefly walk you through it. Okay, I'm not going to walk you through the implementation of this function because it's not particularly interesting and it's really only relevant for my flashcard app, but I do want to point out the basics of creating Postgres functions. So I created this score response function in the learn schema that takes 3 parameters, and it returns this type here, score response, which is this custom composite type I created up here. Now the $$ you see here delimits the start of the function body, and if we scroll down we see another $$ that delimits the end of the function body. Then down here, we see the language the function is written in, and the function is marked as immutable, meaning it's a pure function that has no side effects. And lastly, we see this, security definer, which we're going to skip for the moment, but it's important and we'll come back to it later. Okay, so you're probably wondering how this function gets used. Well, hold that thought. I'll show you in just a few moments here. Next, I'm going to go ahead and add the down migration code to drop the function and the custom composite type. Now we'll go ahead and apply our migration, and I'll create another migration for another function that will handle scoring. In other words, we're going to create a function that will get called when these buttons get clicked in the app. Next, I'll open our new up and down migration files, and I'll add a function offline, and I'll walk you through the basic logic in this function. So this handle score function takes 2 parameters, the card ID and the score for how well the answer was remembered. Basically, if the user clicks this button, the score is 0. Clicking this button means the score was 1, the score for this button is 2, and this button's score is 3. The return value for this function is a row from the card table. Right here, I defined a few variables, which get used in the body of our function. Now in this block, I'm querying a card based on the past card ID and storing the result in this card variable. Then on this line, I'm calling that other function we just finished creating, and I'm storing the return value in the response variable. Next, I'm setting a new review after timestamp to be the current review after time, plus some spacing value in days. Now in this block, I'm updating the card, setting the column values that the users aren't able to manipulate, and I'm returning the updated card row into the card variable. Then right here, I'm simply logging or inserting the user's score into the response table, and lastly, I'm returning the card. Okay, after the body of the function, you see the language used in this function, and you see that this function isn't marked as immutable like we saw in the last function. It's marked as volatile because it's not a pure function. We've got side effects happening in this function. And lastly, we see this security definer syntax again. Now in the down migration, I'll drop the function. Next, I'll apply our migration. Okay, at this point, you might be wondering, what do we do with this handle score function that I just created? Well, you call the function when these buttons are pushed, which begs the question, how do you call this function with Postgraphile? Well, as you might have guessed, Postgraphile automatically adds the handle score function as a GraphQL mutation that you can use. Let me show you how. So I'll create a new mutation, and I'll key the letter H, and check it out. We see our handle score function, or more accurately, it's called a field in GraphQL. Alright, so to call it, you'd create a mutation that looks something like this. Okay, the next thing I want to work on is creating a GraphQL query to find the next flashcard that should be reviewed. In other words, when you're on this home page and you see that there are 3 cards to be reviewed, so you click the Begin Review button, which should take you to the review page, well, we need to write a query that fetches the next card to review. In other words, this card we see right here. But before we start on the next card query, I want to insert a few more card rows, so I'll run this insert command right here. Okay, so we really need to write a next card GraphQL query that's sort of like this SQL query you see here. Basically, we need to query for cards that have a review after timestamp less than or equal to the current time, and the card shouldn't be archived, and the card must be for a given person. Then we want to order the cards by the review after timestamp and only return the top card, but again, we need to do this type of query in GraphQL. Alright, we'll start with this next card query, which returns all these cards. Then we can add some sorting, filtering, and limiting on the query by adding some parameters to the cards field. So I'll start by saying order by, the review after field in ascending order, and running this query works, but we've got more to do still. Next, I'll say only return the first one card, which gets us closer to what we need, but we still need to filter the cards to only show the cards that are past due based on the review after field. There is a condition parameter where we can choose a field to filter with, but what would I put here? Well, this condition is problematic for what we're trying to do. This condition parameter only allows us to do equality comparisons, so I could filter for a card with a specific timestamp. That's not what we're trying to do. What we want to do is something like this, where we'd say review after is less than or equal to some date value, but this isn't valid syntax, so it won't work. Okay, so are we stuck, or is there some way to get around this? Well, I'm sorry to say we're stuck. It can't be solved. Of course, I'm kidding. This is easily solved. There's a couple of solutions that come to mind. I'll show you both of them. One possible solution is to create a database view. So to create a view, I'll create a new migration. Then I'll open up the new migration files. And in the up migration, I'll create a view in the learn schema named next card. Then I'll add a select statement where I select every column from the card table where the review after date is less than or equal to the current time, right now, and I'll order the results by the sequence, review after, and ID. Next, I'll handle the down migration by dropping the view. Now I'll apply the new migration. So how do we use this new view in Postgraphile? Well, I bet you could intuitively guess the answer at this point. Basically, Postgraphile exposes the view as a query field similar to tables. So let's create a new query that uses this view in Graphical. I'll go ahead and press Control Space to see what fields are available to use. And as you can see right here, there's a next card field. So I'll go ahead and use it. And I'll create a query that includes the ID, question, and answer fields. Then I'll run the query. Okay, we still see more than one card, which isn't exactly what we want, but at least we know that they're cards that actually need to be reviewed, and they are in the order we want them to be reviewed in. Now all we need to do is modify this query so that it only returns one card. So I'll add the parameter to the next card field, where I ask for the first one, then I'll run the query again, and as you can see, it worked. There's another way we can handle this next card query, which is to add a Postgraphile plugin that enhances the filtering capabilities. Let me show you how to do this. So first, I'll kill the server, then I'll install the Postgraphile plugin connection filter library, or plugin. Next, I'll modify our server shell script by appending another plugin right here by separating the first plugin from the next plugin with a comma, then including the plugin module name. Now I'll go ahead and start the server again, then we'll try out our new filtering capabilities in Graphical. I'll change the next cards field to just cards, then I'll get rid of the custom parameter first, and I'll press Control Space to show you the autocomplete list. So do you see any new parameters in this list? This filter parameter is new. It's made available by the plugin we just installed. I'll go ahead and select the filter parameter, then I'll choose the review after field, and then inside a new set of curly braces, I'll trigger the autocomplete list and check out all these different filtering options. In our case, I'd like to use the less than or equal to option, and then I'll add in a date time value. Now I'll add the first one parameter again. And of course, we'd need to set the order by as well, but for now I'll skip that and just try out our query, and as you can see, we're able to filter the date as needed. Okay, we've basically implemented the required tables, views, and functions to implement this app, except we still need to handle some security-related things, such as user registration and user authentication. So let's deal with this security-related stuff. The next thing we'll do is create a new migration, or we'll create a new schema. Now I'll open up the migration files, and in the up file, I'll create a new schema named learn private, and in the down schema, I'll drop the learn private schema. Okay, you're probably wondering, what's this learn private schema for? Well, hang with me, you'll see in just a moment here. Next, I'll go ahead and run the migration, then I'll create a new migration for a new table called person account. Now I'll open the new up and down migration files, and then I'll create a new table in the new learn private schema named person account. Then I'll add a person ID column of type integer, which is the primary key, and it references the learn schema's person table by the ID column. And I'll say when this referenced relation is deleted, cascade the delete to this table. Next, I'll add an email column of type text that can't be null, and I'll add a simple check on the format of the email. This validation isn't sufficient, really, but I don't want to add a ridiculously long regular expression right here, but I hope you get the gist of what's possible in the way of data validation. Lastly, I'll add a password hash column of type text, which can't be null. Okay, so what's this person account table for? Well, as you might have already guessed, it's for storing the sensitive information about a user's account, the email and the password hash. Can you guess why we put this table in the new learn private schema? Well, because we don't want to expose this information via Postgraphile. In other words, we don't want there to be GraphQL queries that can return this information. Okay, so how is it that putting a table in this learn private schema prevents users from querying it? Well, let's look back at our server shell script, and in particular, look at this option right here, the schema option. With this option, we're telling Postgraphile to only expose tables, views, functions, and so on if they reside in the learn schema. So by putting our sensitive information in another schema, we're ensuring that it won't be accidentally leaked. Okay, one more thing in this up migration, I'll add an index for the email column, then in the down migration, I'll drop the person account table. Now I'll go ahead and apply our migration. Okay, we're going to need to hash the user's password, as it's a best practice, and we'll do so using the bcrypt hashing algorithm. But to use bcrypt in Postgres, we'll need to add an extension. So to add an extension, I'll first create a new migration. Then I'll open the up and down migration files. Then in the up file, I'll create the extension, if it doesn't already exist, named pgcrypto. In the down file, I'll drop the extension. Next, I'm going to create a new migration that creates a Postgres function to register new users. Then I'll open the new migration files, and in the up file, I'll create a new function in the learn schema named registerPerson, which takes the first name, last name, email, and password. This function will return a new person. Then in the body of the function, I'll declare a person variable, and I'll insert into the person table the first and last names, and I'll return the new row into the person variable. Then I'll also insert into the learn private schema's person account table the columns person ID, email, and password hash. The value for the person ID is in the person variable using dot notation. The email is a passed parameter, and the password hash will be generated by calling the crypt function, passing in the password, and assault by calling gensalt and passing in the bf value. Lastly, I'll return the person variable and close out the function body. Then I'll include the function's language, I'll mark it as strict, and I'll add security definer. Okay, as we've seen before, this function will become a GraphQL field that we can essentially call with a GraphQL mutation. But let me ask you a question. Is there anything in this function body that bothers you or seems problematic? If you don't see anything that bothers you, let me give you a small hint. Here's the hint. This registerPerson function will be called by random users on the internet when creating an account. So, do you think both of these inserts will work for random internet users? In particular, what about this second insert, which is touching a table in the learn private schema? Okay, it might seem concerning that an untrusted random internet user can insert a value into the private schema, but it's actually desirable in this case, and it's possible because we're using this line right here, security definer. Basically, by adding security definer, we're telling Postgres when it runs this function, regardless of who calls it, run it with the permissions of the user who created the function. In other words, always run this function with the permissions of the user who applies this migration. Well, there's a bit more to the security story, but we'll get to that in a moment here. Okay, next I'll go ahead and create the down migration, which drops the function, then I'll apply the migration. All right, let's try out this new registerPerson function. So here's a GraphQL mutation that effectively calls the registerPerson function, passing in the relevant input parameters, and it returns the new person's ID, first and last names. Now I'll attempt to run this mutation, and it worked. Cool. Okay, now that our Postgraphile server can register new users, the next task is to create a way for existing users to sign in or authenticate. But before we deal with authentication, we need to create some database security roles, one of which we're going to assign to users upon successful sign-in. So I'll make a new migration to create some roles, then I'll open the migration files, and in the up migration file, I'll start by creating a role named learn Postgraphile, which is a role that can log in with the password secret password. This is the role that we'll have Postgraphile use in the server shell script in just a moment. Next, I'll create a role named learn anonymous, which is more like a security group than a user account, and this role will get used for non-signed-in users that make requests to the Postgraphile server. You'll see exactly what I mean by this in just a moment. Now I'll go ahead and grant the role learn anonymous to the role learn Postgraphile. You can think of this command as saying anything this role can do can also be done by this role. This will make more sense when we start granting privileges to this role in a few moments. Next, I'll create a role named LearnPerson, which is the role that authenticated users will be a part of. And lastly, we'll grant the LearnPerson role to the LearnPostgraphile role. Okay, let me quickly summarize what's going on in this migration. On this line, we're effectively creating a database user with a password. Then on these two lines, we're effectively creating two security groups, one for signed-in users and one for anonymous users. Then we said anything these security groups can do can also be done by the LearnPostgraphile role or user. In the down migration, I'll drop all three roles. Next, I'll modify the server shell script, and in particular, I'll change the connection string to use the LearnPostgraphile account with its corresponding password, and I'll specify that the server is running on the local host. I'm also going to extend the command and add the option owner connection, which I'll pass in a connection string that uses my local superuser account. The only reason I'm adding this connection string is because this account here isn't going to have the necessary permissions to watch for schema changes. Keep in mind, in production, you wouldn't actually use either of these options on the bottom here. Next, I'll add another option, default role, and I'll pass along the role LearnAnonymous. Basically, this tells Postgraphile that if a non-authenticated user makes a request to the server, give them the permissions associated with this role. Of course, we haven't actually assigned permissions to this role yet, but we'll do that in a moment. Okay, I'll go ahead and apply our migration, then I'll restart our server so that it runs with all our new options. We're about ready to deal with user sign-ins, but there's one more thing we'll need to add first, a special Postgres data type we'll use to generate JSON Web Tokens, or what's commonly called JOTs. If you aren't familiar with JOTs, they are essentially a cryptographically signed token that gets sent to the user upon successfully signing in. Then on every subsequent request the user makes, they'll send the JOT to the server as a form of authentication. You can think of a JOT as an alternative to cookies in the browser. So to define our new JOT data type, I'll create a new migration. Then I'll open the migration files, and in the up file, I'll create a type in the learn schema named JOT, which is a composite type that includes a role field of type text, a person ID field of type integer, and an expiration of type big integer. So basically, this type here is a representation of a security token that will get sent back to the user when they successfully sign in. You'll see this in action in just a moment. In the down migration file, I'll drop the JOT type. Now to make use of this JOT type, we've got to pass a couple of new options to Postgraphile. First, we need to tell Postgraphile what composite type to use when generating the JOT. To do this, I'll pass in the JOT token identifier option, then I'll pass in the name of the new type we just created. Next, we need to provide a secret passphrase that Postgraphile will use when it signs the tokens upon user sign-in, and it'll use this secret to verify the tokens haven't been tampered with when the server receives GraphQL queries from authenticated users. Okay, I'll go ahead and run our migration, then I'll kill the server and restart it. Now we can finally create a function that handles user sign-ins, or authentication. So I'll create a new migration, then I'll open up the migration files. Next, in the up migration, I'll create a function in the learn schema named authenticate, which gets passed a user email and password. The function will return the JOT type we just created, then I'll declare an account variable of type person account. Now I'll select star into the account variable from the person account table, where the email equals the email passed as a parameter here. You'll notice that I'm qualifying the email with the function name here to avoid ambiguity between the email parameter name and the email column name in the person account table. Next, we'll check to see if the provided password is correct by saying if the account password hash equals the value returned by calling crypt, passing in the password, and the account's saved password hash, then we'll return a new JOT type, which is created by keying an opening parentheses, followed by the role of learn person, followed by the person ID, followed by the expiration time as a Unix timestamp, which is the current time plus 30 days, and lastly, I'll cast this new composite type as a JOT type. However, if this password isn't valid, we'll just return null. Next, in the down migration file, I'll drop the authenticate function. Okay, I'll go ahead and run our migration, and now I'll go ahead and create a new migration to assign permissions to the roles we created a few moments ago. In the up migration file, I'll start by altering the default privileges to revoke the execute permission on functions from the public role. In a moment, we'll selectively grant execute privileges to the functions we've created. Next, I'll grant usage on the schema learn to the roles LearnAnonymous and LearnPerson. Now I'll grant privileges on the function registerPerson to the role learnAnonymous. In other words, we're saying it's okay for anonymous users to call the registerPerson function. Next, I'll do a similar thing to the authenticate function, allowing both the learnAnonymous and the learnPerson roles to call it. Now I'll grant a similar privilege to the handleScore function to only allow usage by signed-in users, which are people in the role learnPerson. Next, I'll grant all privileges to the table person to the role learnPerson. In other words, people who are in this role can do inserts, updates, deletes, and selects on this table. Now I'll grant select and delete privileges on the table card to the role learnPerson, and then on the next line I'll grant insert and update privileges on the ID, question, answer, and archive columns of the card table to the learnPerson role. I'm just going to add the final few grants and then I'll walk you through them. So this line gives users in the learnPerson role the ability to use the sequence here. Basically, this sequence is what auto-generates the unique ID when new cards are inserted. This line lets signed-in users do selects on the response table, and this line lets signed-in users do selects on the next card view. Okay, hopefully the puzzle is starting to come together for you on why we created roles. Roles allow us to control access to all the different parts of the database. Alright, in the down migration, I'll essentially reverse everything I added in the up migration. Next, I'll run the migration, and now we can go ahead and try out our sign-in functionality, which is to call the authenticate function. So in GraphQL, I'll create a new mutation named authenticatePerson, but this time I'm going to use GraphQL variables in the query. Let me show you what I mean by variables. After the name authenticatePerson, I'll add a set of parentheses, then I'll define an email variable that starts with a $, and I'll say it should be of type string, and I'll add an exclamation point on the end, which means it's a required parameter. Then I'll do a similar thing for the password. Next, I'll enter the authenticate field name, and I'll add the input parameters, where the email parameter is the value in the email variable, and the password parameter is the value in the password variable. Then I'll ask for the JOT to get returned. So are we done with this query? Let's try it. And it failed, as you probably expected, and we're getting an error response indicating the email and password variables weren't supplied, which of course is true. We didn't provide an actual email and password, but we can do that down here in the Query Variables panel. So I'll click on the label Query Variables, which expands the panel. Then I'll add some JSON, which includes the email key with the corresponding email address, followed by a password key, and the password we used earlier when we registered this user. Now I'll run the query again, and it worked. And what you see right here is the JOT. So what's the point of using GraphQL variables? Well, with variables, you can reuse a query with different inputs without having to do any sort of string concatenation. Let's take a look at the JSON Web Token that was returned here. To help you better understand what this JOT is, I'm going to copy it to the clipboard, then I'll open up the website, jwt.io, then I'll paste the JOT into this input, then I want to draw your attention to this section over here. Basically, this site decodes the JOT into its three component parts: the header, the body, and the signature. The interesting part is the payload here, or what's often called the claims, which, as you can see, includes the role, the person ID, the expiration timestamp, and a few other claims that Postgraphile added on its own. Now, when a signed-in user makes a request to the server, they'll send the JOT along with the request, typically as an authorization header in HTTP requests. Then the server will verify the token hasn't been tampered with, and then the server can use the values in the payload as needed for security purposes. Okay, let's try using this JOT in GraphQL. To include the JOT with GraphQL requests, I'm going to use the mod header Chrome extension, and I'm going to get rid of this other JOT that I was using for something else. And I'll paste in our new JOT. Then I'll click the checkbox to add this authorization header. Next, I'll add a card query, and actually, let me remove the authorization header first, and I'll run the query. And as you can see from the response, permission was denied. So I'll go ahead and add the authorization header and run the query again, and this time it worked, which is good. But do you notice any problems in this response? Let me give you a hint by adding in the person ID field and running this query again. So do you see the problem now? Basically, we're running this query as this signed-in user with a person ID of 7, but we're seeing cards from other users, which isn't good. Each user should only be able to see and manipulate their own cards. However, this can be easily addressed by enabling a feature in Postgres called row-level security. I'll show you how this works by creating a new migration. Then in the up migration file, I'll alter the table card to enable row-level security. Next, I'll create a policy named selectCard on the card table for select SQL commands, and I'll apply this logic to the role learnPerson using the following Boolean logic. I'll say selects are only allowed when the person ID of each row equals the following expression. Okay, so let me explain this expression. When Postgraphile receives a JOT, it temporarily saves the payload or claims of the JOT to the database connection session, and this current settings call allows us to access the JOT's claim values. So basically, when this JOT is sent to the server, which has this person ID set to 7, we can access the person ID like this. So essentially, with this policy, a given user can only see rows in the card table that have their own person ID. I'll add similar policies for updates, deletes, and inserts. The only significant difference between these policies is that the insert policy uses with check instead of using. The difference here is that select, update, and deletes have existing saved row values to check against, so these checks happen before the corresponding SQL command occurs, but since inserts don't already have row values to check, what happens is the insert occurs, then this Boolean expression is checked, and if it fails, the insert fails. Now in the down file, I'll simply reverse everything I did in the up migration file. Okay, I'll go ahead and apply the migration, and I'll run this query again, and this time the query works, but we don't see any of the cards because the existing cards don't belong to the signed-in user. All right, let's go ahead and add a new card using the following mutation. Actually, do you think this mutation will work? Let's try and see. It failed, and it's complaining about a violation in the row-level security policy. So here's the problem when we're running this mutation. The person ID isn't being added to the card, so the insert policy is failing. Okay, so how do we get the person ID column populated when creating a new card? Well, it's not a value we'd want to send as a parameter because we just can't trust users on something like this. However, there is a way of handling this using database triggers. Let me show you how. I'm going to create one final migration. Then I'll open up the migration files, and in the up file, I'll create a function in the learn private schema named setPersonID, which returns a trigger. Then in the body of the function, I'll use the new keyword, which represents the new row to be inserted, followed by a dot personID, which I'll set to the person ID from the JOT, which again you can access by calling current settings and passing in a string representation of the claim value you're wanting. So JOT claims person ID, then I'll just return new and close out the function. Next, I'll create a trigger named cardPersonID. Then I'll say, before insert on the table card, for each row, execute the procedure we created up here, learn private, setPersonID. Now in the down migration file, I'll simply drop the trigger and the function. Okay, let's apply this migration, then we'll try running the create card mutation again, and this time it worked. Cool. Now let's see if we can get any data from the card query. And we do now. We get the one row we just inserted. Cool. Okay, I think we're mostly done. So the next question you might have is, how do we take GraphQL queries like these and use them in applications like our flashcard app, or a mobile app, or a native app? Well, I haven't really pointed this out, but when you start Postgraphile, you see the API endpoint it exposes right here. In our case, it's an HTTP endpoint that accepts POST requests, but if we were using the real-time features of Postgraphile, it would also accept WebSocket connections as well. And if you use Postgraphile as a Node.js middleware, you could potentially accept requests in other ways, such as with HTTP GET requests. Now, since Postgraphile is just using HTTP for transport, you could send requests similar to how you might make REST API calls by using the Fetch API or a library like Axios. However, I'd suggest looking at some of the more popular GraphQL client libraries like Apollo, which adds all sorts of nice client-side features. Similarly, for mobile apps and other types of native apps, you'd likely use one of their popular client-side libraries. So what do you think about Postgraphile? I think it's a pretty clever use of Postgres that offers excellent functionality and allows you to build your backend in a fraction of the time it would take with modern programming languages and frameworks. Oh, and keep in mind, there are a ton of features I didn't cover, like the real-time capabilities of Postgraphile. So here's my challenge to you. The next time you're in a hackathon, or implementing a prototype, or creating a side project, or just starting a new project at work, consider using Postgraphile. I'm pretty sure you'll save yourself a ton of time, and you'll probably really enjoy using it. Additionally, if you end up using Postgraphile, I'd urge you to strongly consider supporting the open source project financially, either personally or through your employer. This project is mostly maintained by Benji Gillum, and your financial support allows him to spend less time contracting and more time working on Postgraphile. A couple of final words. If you like my teaching style, you should check out my courses at knowthen.com, and of course it would be great if you subscribe to my YouTube channel, and don't forget to click the notification bell. Thanks for watching, and I'll see you next time.